Okay. Well, you know, y'all have the right idea. Let's be really careful and get a good picture of what happens at this point, right? So this point is going to be the point 3, 5, f of 3, 5. Whatever f is, you can do this, right? Doesn't matter what the coordinates of the point are. All we want is a normal vector. Now, if we want to find the tangent plane, then we're going to use these coordinates with that normal vector, and we're going to get the equation of our tangent plane, right? Then we know how to get the equation of tangent plane given a point and a normal vector. Okay, so what we know is that the partial with respect to y is 0.76, right? So means if we have any run here, the rise is 0.76 of the run, right? So here we have a delta y and a delta z. And we have a tangent line, right, with a slope. I'll just use a decimal approximation. These aren't accurate, incidentally. Reciprocal of this is closer to 0.78. So maybe it's 0.77 and 1.2. I don't know. Should be close.
0.775. And
Okay, so it's closer to 0.78. And 1.27 I'll stick with. What do you got?
1.29.
See what I mean? Okay, well, be that way. And check out that calculator because there's obviously an error. Okay, now, we got this, right? Which means that if I want a vector in this direction, you know, I used to have purple chalk, one of my favorite colors. I haven't used it in a long time. I had to go find some purple chalk. I mean, right there, I got boxes of it. Okay, well, here's any vector. Parallel to the tangent line, right? Okay. Now, this vector is in the plane where x is constant, so it has no I component, right? Rise is a k component, the run is a j component, right? So the vector has the form something times j plus the slope times that something times k, right? Well, it's easy to see. Clearly, the rise divided by the run is the slope, which is 3/5, right? Square root of 3/5. In the x direction, well, you're going to have a delta x and a delta c, right? So I can't really conveniently label that here, so I'll just redraw it over here. So we'll have a delta x and a delta z, and we'll have a vector here, okay, of very similar form. And this vector is, for reasons that you can figure out, I plus the square root of 5/3. Okay, right? So the vectors
gosh.
Are I plus fxk and j plus fyk. Always. You don't have to use these, but it's very convenient having a unit here, right? So, the normal could be what? The cross product, right? Now, if you use a determinant to figure this cross product, I'm going to tell you you shouldn't. It's much simpler to just use the distributive law. I cross j is k, right? So you're going to get k. You don't need to put this thing in a determinant and even pervert that worse by extending the determinant 2 more columns and doing this. Okay?
I can do it the other way too, so.
Yeah, if you're in a hurry, okay. I won't really hassle you unless I tell you to do it by the distributive law, but I want you to know how to do that. And this, I mean, if you do that with this one, I'm going to say, why did you do that? Okay? You understand it better if you look at the cross, if you look at the distributive. Anyhow, I cross k. I cross k is negative j, right? So we're going to get a negative fyj, and j cross k is I. Wait a minute.
Okay.
J cross k is I cross k is negative j. That violates all kinds of things. Should have used a determinant. What's the matter with you? Okay.
What are you trying to do now?
K cross K.
Never mind. It's this cross this. Just, Okay, and of course you would want to write it out so you keep it straight. I was doing the cross product, this cross this, right? And then I did this cross this. Well, the cross product is not commutative, okay? It's anti-commutative. So, and I knew that was wrong because it violated all kinds of things. So right there is your normal vector. If you want a unit normal, it's just this divided by the magnitude of this, which is 1 plus fx squared plus fy squared. Very simple formula, but if you remember where it comes from, you don't need to remember the formula because you can always reconstruct it very quickly. And if you're not using it frequently, it's a lot less baggage to remember how to develop it than it is to memorize it, unless you've got a really good memory. And many people do, so there's really nothing wrong with that, but I guarantee you 5 years later, if you haven't looked at this, you're more likely to remember how it's developed than you are to remember the formula. I don't guarantee you that. I just said I do. I don't. Some people, if you really understand this, I think you're more likely to remember the picture and the idea than you are the formula. Okay?